Hello, welcome back. As you can see, I've gotten done soldering all of these boards, replacement capacitor boards. Put everything on there, but you can see from a production one here, a real one, that we're missing a few parts. These pulse transformers and the mounting hardware here. So we're going to have to add that to some of these. Now I've got a few of them. I'll go ahead and this is pretty for the picture, but they're kind of in my way, so here, I'm going to pause it while those magically will disappear. Okay, so as you can see, I've cleaned up a little bit. We've got 3 boards here. Well, 4 boards, 3 replacement cat boards and 1 original. And we're going to put the hardware in on these boards. However, we want to do a few, there's one little thing I need to do before I do that. And I can show you. Some of these boards that have exploded, which is the whole reason why I do the capacitor replacement board, you can see that these ones have been removed from there. And see, like this one, it's got a lot of the magical smokes come out. You can see on this board they glued them in, the other one they didn't. I have all these pulse transformers. They are conveniently located right here. So here's one pulse transformer set with hardware, and I'll put that over here. Here's another set right here with hardware, and my last set came from those guys, and you can see it's a little charred. So we need to check a few things. We're going to make sure that these are still good. Oops, especially now after I dropped it. We can clean off, if they're still electrically intact, we can clean them off and they're probably fine. It does look like it's all just cosmetic. It doesn't look like the wires are actually melted or anything like that. So if not, we need to have the schematic for these pulse transformers, which should be pretty simple, but we can create that, and then I have the other hardware for that. So that's what we're going to do next. Before we install everything onto the new boards, we want to make sure that we have the schematic for them in case I ever have to make them, because this is pretty simple to make. It's just ribbon cable that's wrapped around here 10 times, so that's pretty easy to do. So if we need to make new ones, we can make new ones. It's not that big of a deal. But for now, we're going to draw a little schematic of some transformers. We'll ohm them out. So I'm going to clear this off again. I probably should have just done that in the first place. So I'll be back in a second. Okay, so I'm back. So of this group, we have one set that still has pin 1 markings on the ribbon cables. So that we're going to use these ones to ohm everybody out. Since the other ones don't have any pin 1 markings on them, they're just kind of built out of, they probably bought a 50-pin ribbon and just stripped it as needed. But luckily we've got one set with pin 1 markings on that, so that makes ohming it out a little bit easier. And so we're going to shove all these guys off camera here. I'll just shove these into over here. And we don't really need a little block, so we'll move them over here. But we want these guys. Because one thing we need to establish is there a difference between these two transformers? They look identical, they look the same, they look like they're wrapped the same number of turns. I would assume that they're identical, since I don't see any special markings like on this set here. There's nothing that tells you that they're unique from each other. So I would assume that they're the same, but we need to actually confirm that. So first thing we're going to do is grab some paper and some pens, because I don't never remember which one's actually the dead one. I should just throw away the bad one. Trusty ohm meter, and we're going to draw out the schematic for these guys. So I'll grab my chair here. Let's see how much time we got. 5 minutes on there? Plenty of time. So using continuity check, let's do the little guy first. We can look at the cable here, and we definitely see that there's just it's a 3-wire ribbon cable that's been run through, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 times on this one. So we got a coil 9 times, and we've got a 4-pin connector and a 5-pin connector, and we can see that both pin 1s are over here, so we're going to assume that this is a coil, this is the other coil, and then this is the input. So this will be the input and 2 outputs. So what is this doing? It's a pulse transformer of some kind. Could be transferring over power to the gate drivers, since it's got 1 input and 2 outputs, but I'm not 100% sure. I'd have to go look at I'd have to go look at the schematic to see. But in this case, we don't really have to ohm it out, because we probably can guess the schematic here. I'm going to guess that these two are shorted together, and they are, and that we know these two are because they're both pin 1, or cable marked pin 1, you know what I mean, the red stripe. So that leaves the other 2, and by looking at how these come in, we can see that this is driving both the middle wires of the 3, and these guys are on the one side, and then the other one's on the other side. Now, one important thing is the direction, like which way the pins are, because as current goes through one direction, it goes through the transformer, and it comes out one way on here, and then when it reverses, it's going to come out the other way. But they might have them flipped so that it's kind of doing a push-pull. So we'll have to look at that more closely. But first off, let's just draw our little transformer here. So we're going to have a coil, a core of some kind. So we've got our core here, and we know that this has got the 2 pins coming in. So we'll go ahead and do that, and then we know the other side's got 2 coils coming out. So I'll put this way. Alright, so if we look on here, another thing we should do is we know we have essentially 3 wires in this cable, and then they're wrapped around, we counted 8 times, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, so there's 9 turns. We write that down. Should probably also get the dimensions of that, but let's not get ahead of ourselves. So we know, so we're going to go from, I don't know if you'll be able to see on here, but these are actually numbered. Let me see if I can get it in the light just right. No, not happening. But molded in the plastic, this is pin 1, pin 2, pin 3, and pin 4. Probably can't see that, but trust me, it's there. So we know we want to do everything with respect to pin 1 on, this is the input. I guess we could do everything with respect to this, since we know we'll do everything with respect to this guy, since it's actually pin 1. So if we go, so this is the same way, it's pin 1, 2, 3, 4, and 5. So if we trace pin 1, it is going, so we want to know which side it's going. So it's going on to this side right here. So we want to do everything with respect to this wire, because that determines our coil direction. So we've got pin 1 coming here, and it goes to the top, and then it goes around and then comes out this way. So that's going to the 5-pin connector. So we would say, we'll go ahead and write down, this is the 4-pin connector on this side, and this is the 5-pin connector on this side. And we've got pin 1 from the 5-pin, So we know this is going to be, that's the output. We got pin 1, and then that returns on pin 2 of that connector, because we already knew it went out and comes back in because those are the red wires. Now the next tricky part is we're going to trace this back, and it looks like it's pin 1, 2, 3, 4 is the same direction, and then 5 is the return. So 4, I'll do 4, and then return is 5, right? And now the middle pin here, or the middle wire, is going across to pin 1 on here. So we know that this is going to be the input, and then the return, and that's going to be pin 1, and that's pin 2. So that's the schematic of this little coil. And we also know now this side, which we can keep it, here, I'll do it again here. It's kind of, we derive this at the same time we drive this, but pin 1 on the red wire, so if we look at pin 1, so that's the 5-pin connector, pin 1, and that goes to the 5-pin connector, pin 2, right? That's essentially this part, and we know this guy, we can come in here, we know that the 4-pin connector of pin 1 goes straight across to the 4-pin connector, pin 2, and then that leaves the last one here, which we deduce to be the 5-pin connector, pin 4, goes straight across to the 5-pin connector, pin 5. Does that make sense? So this is connector, the 5-pin connector, 4-pin connector, 5-pin, and so they're obviously push-pulling on this, and that's generating 2 isolated outputs. So these could be bridge rectified, could be used for 2 separate isolated power supplies. Not sure. I have to go reverse engineer more of the schematic. But we know that that's what's going on in this little 3-pin ribbon cable here, or 3-wire ribbon cable for this little guy. And that's it for that. So the next we've got to do, oh, you know, actually, yeah, that's okay. I want to actually measure this in case I ever have to make it from scratch, and I could buy the core, the ferrite core there. So the next thing we're going to do is the big transformer. So let's make this we'll call this the small pulse transformer. And then we'll work on the large and in charge pulse transformer. Okay, we're going to do the same exact thing we just did, except we'll draw him. We'll make him bigger because we got more wires on it. So, given what we learned from here, this is probably going to be the same. We already know that these 2 pin 1s are right next to each other. This is a 5-pin or 5-wire cable, so we can draw those out. So we got 1, 2, 3, 4, 5. And now we can figure it out. We'll ohm it out. So we already know that these 2 are going to be connected just from the wire alone, the wire coloring. Yeah, so these 2 are probably going to be, yep, and these 2. So we've got, and if we go between anybody else now, so we got we got a 6-pin connector and these 2, so we got essentially 3 coils, and then on this side, same thing where we've got a gap in there, so I'm pretty sure, yeah, we're going to have 2 coils, and then they're not connected together at all. So we got 2 coils coming in and 3 coils coming out. So we can draw that. Go ahead and draw 1 coil here. So there's our 2 coils coming in, and we've got 3 coils coming out. My crude coil drawing skills. So there's our 3 coils. I can fix my core there. So we're going to do the same thing. We're going to have an input, an output, input, output, output, input, return, I guess. So we should be able to figure out from here, and then we're going to do, we've got a 6-pin, and the other one was 5-pin. And how many turns do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so 10 turn coil. It's got 10 turns, and we already know that these two are pin 1. Pin 1 and 2 on here go straight through. So we're going to do it the same that we did on the last one. So this will be pin 1, that'll be pin 2, and by using that we can reference everything. That allows us to figure out if they've wrapped them in different directions. Now that I think about it, I don't think it's actually possible. Well, no, they could be, because they could flip the pins in the connector to change the polarity if they wanted to, like if they were doing some kind of push-pull. But it didn't look like this one. It didn't. It was exactly the same. So they could have flipped the order and made that 5 and 4, and then when you put current through this way, it would push out here, but then pull in the other way. You know, so they'd be out of phase with each other. But it looks like they're all in phase, which leads me to believe that these are power supplies rather than, well, at least this one is. Well, we'll find out about this one, because they'd probably use optical isolators or something for the actual, to tell the gate drivers to fire, maybe? I don't know. I'd have to look at the schematic, which we don't have. We'd have to reverse engineer schematic, I guess, to figure out what's going on with that. Anyways, where was I? Oh, yes. Easily sidetracked. So, pin 1 is this guy, and we're going to trace that through to the upper one. So, kind of separate these guys out. Here we go. Do you see what I'm doing there? Because I've got the coil coming in on both sides. So if I do this, see how I'm separating it out? Right? So then I can track this. We know this is pin 1 because it's marked red. It goes to pin 1 on this connector, and that allows us to establish which side's current's coming in or going out of, and then we can do everything with respect to that. We don't need to know which direction it's happening, just that everything is done with the same respect, so we don't accidentally reverse a flow or anything like that. Does that make sense? So we're going to go pin 1, and we're coming in here, and then we go around here, and then we come out and return to there, to pin 2. So I already got that. So the next wire over is wire number 2 goes to the 5-pin connector, pin 1. So that goes pin 1, and we know that that goes next door, and so that returns on that. So we know that that's pin 1 and that's pin 2 on that 5-pin connector. And then the next one is the middle. Middle wire goes over to pin 1, 2, 3, pin 3. And then we know that the return is on pin 4 already from when we ohmed it out. And then the next guy over goes down to pin 1, 2, 3, 4, and 5 on the other connector. And then the last pin, or wire number 5, goes to pin 5. And then know that returns on 6. So yeah, they didn't do any kind of crossing or anything. That's convenient. So those are the same. And then the last thing we need to do is figure this out. So we know that that was the 6-pin was the first wire. So we know that that's 6-1, and it went across to 6-2, and then this guy was 5-1, and it goes across to 5-2, and then the next wire was 6-3, and it goes across to 6-4, and my thing's been on for too long, and 5-4, and it goes across to 5-5, and then 6-5. 6-5 goes across to 6-6. So we should have 6-5, 6-5, 6, 6-5, 6-5, 6, 1, 1, 3, 4, and 5. So yeah, 1 to 2. Yeah, that looks good. There we go. So that is the schematic of this guy. Now we need to figure out if this guy is the same. I'm going to assume it is because I don't see, otherwise they'd have different part numbers, or somebody would, you know, had marked one saying this is the left and this is the right, or, you know, there'd be some kind of important thing going on with that. But let's just double check. Yeah, that's the same. And these should all be individual coils. Yep. And yep. So that looks the same. The only thing we need to check is, see, this doesn't have the pin 1 marking, but we know from here, we can, since we referenced everything, we can go like this, and we can do this, and now we've got it broken out with respect to pin 1, which is going down here. So I know pin 1 is the one marked pin 1, and it goes to here, which is, and then the next wire over should go to pin 1 on the other connector, and it does, according to our schematic here. And then the next wire, so the middle wire should go to pin 3 on connector 6, and it does. And then our next wire goes down to pin 1, 2, 3, 4 on the 5. Yep, 5, 4. And then the last one should be 6, 5. And if we trace that back, that goes to 6, 5. Yep. So we know that this is the same. Let's double check the other side here. Oh, we know it has to be the same because everything went like that. Yeah. So we know that they're identical. So both of these guys are the exact same connectors. And the horrible beeping that's going on is my battery pack on the UPS has decided to die and needs to be changed, and it's complaining because it just failed its self-test. The annoying beeping will stop momentarily. If you can even hear that, I don't know. So one other thing I wanted to check was the actual physical dimensions of these coils. My trusty caliper here. So we're going to test my drawing skills to make a toroid. What's a toroid look like in 3D? Like that, right? Yay, it stopped. Right, that's a toroid. Like kind of edge on. Except I need the hole. I don't know, that's the inside diameter. Yeah. That's good enough. Right? Yeah. But this one's a little bit bigger, so I'll make it a giant toroid. Guess I could draw it. Yeah. I'll just draw like that. That's that. And that was that. Do you even see that? That? And that. Really crummy drawings. Let's see. We're going to be metric, apparently. Right? Yeah. It's probably 16 millimeter. Doesn't make any sense in inches, yeah. Alright, so we're probably metric. So we know this is 16 millimeters. I guess the question would be, what kind of material is this? I have no idea what the permeability is of this. So it'd be really difficult to actually get the exact same stuff, but it's pulse transformer. You know, you just want to maximize energy transfer. So it probably isn't anything exotic. That looks exactly like it's supposed to be 37 millimeters. And then it's an easy way to measure that. Just squish it over a little. There you go. About 7 millimeters. And then the inner part here is going to be really hard to measure. We'll call it 23. Does that make the math work out right? I think it's actually supposed to be like 22.5. So 7 plus 7 is 14. So 23. Yeah, okay. Yeah, no, 23. That's pretty close. So we'll call it 23 millimeter. I mean, these dimensions have to add up to that dimension, right? So yeah, that's it for that. We know how many turns. Yeah, so I think we've described that pretty well. And then let's get this little guy right here. Maybe. I want to say that's about 6.5 millimeters. And then, I don't know how I'm going to get the length. I don't know, I want to say that's like, it could be 16.5. It's kind of hard because I can't get a good measurement across there. I bet it's close to 16.5. So I do that on the bottom of that one. So you got 16.5 millimeters. I have no idea how I'm going to measure the inside of that. But I can kind of spread the coil there and try to get this. It's not a very thick. I'd say, I'd say it's about 3 1/4. Seems a little odd, but 3.25 millimeter, not inches. Millimeters. And then I'm not going to be able to measure the inside of that, but if we do some math, oh yeah, that's probably correct, because look, that comes out to, so that'd be yeah, 6.5 if you add that up, which means the inside's probably exactly 10, which would make sense. I mean, if that was a 10, yeah, that's 10 millimeter. Yeah, that looks about right. What do you think? Yeah. Probably 10 millimeter. So I think that describes both of those in case I ever need to. And this is a Panduit crimp and poke. I forgot what the actual, is crimp and poke an actual trademark name? That might be a trademark name. That might be 3M's name. I don't know, but these say Panduit on them, but it's just 0.1 spacing, so you could solder wires onto a pin header to stick it in there. So yeah, that would be fine. The connectors don't need to be exact, don't need to be the same connectors. So what else? Oh, before I turn this off, I probably ought to describe these in case I ever need to machine one of these blocks. So it's exactly 10 millimeters. So we do actually, yeah, we'll just draw this guy as a happy cube. Alright, he's got a hole drilled in the middle, and he's got 2 holes on the top. And he is 10 millimeters exactly deep. His height is also 10 millimeters.